All right, so I'm looking for the exponent of 2 that would give me a 6. So somebody suggested 2 to the 2.5. It's a good educated guess. What did we get? 5.65. Okay, so do we need to go higher or lower? Higher. Anybody have another suggestion? 2 to the what? 2 to the 2.6. Tell me what that is. Oh, I went over. Anybody have another suggestion? Something? 2.55. Somebody try 2.55 for me.
Nope.
How much is that?
5.8.
5.8? Okay, too low. What do you think? We'll do one more. One more. I know the fourth time is going to be a charm. We're going to hit it. 2.56? Let's do 2 to the 2.56. What is that?
It's whoever just said 0.58, they're closer. It's at 5.97. So it's above.
Okay, 5.8, 5.97. So, okay, so we could sit there and we could do this all day. And you know what? Maybe we need to look at 2.587. Maybe we need to look at 2.5873. Maybe we really need to look at 2.58734592234. Maybe that's the exponent that we need. Okay, what did you say? That'll take forever. Luckily, there's a way. Let's just restate the problem. What is it that we're looking for? We're looking for the what of 2. What's the word?
Power.
The power, or what's another word for it? The exponent. Okay, let's just stress. We are looking for an exponent. All right? Math has a solution when we're looking for an exponent. You know what the solution is? It's a logarithm. Okay? To answer this question, what we need is a logarithm. Okay? It has nothing to do with a tree or a log. It has nothing to do with music or rhythm. It's just a logarithm. Okay? A logarithm answers the question of what exponent of a given base will result in a specific value. So, we need a base and an exponent, right? Base and an exponent. That's the relationship that we're looking for. A logarithm gives us that exponent if we have the base. So, let's take a look at some logarithms. Here is everybody's favorite power. 3 to the power of 2 is 9, right? Let's look at the elements here. The 3 here is the base. The 2 is the exponent. So for a minute, what I want you guys to do is I want you to flip your calculators face down. Flip your calculators face down. Everybody, please. I'm going to give you 2 more seconds to do that. Thank you. Okay. So 3 to the power of 2 is equal to 9. 3 is the base. The exponent is the logarithm. The exponent is the 2. Okay? Now, if we were looking for the base, if we were looking for the exponent, I'm just so excited, my words are getting jumbled up. If we were looking for the exponent, then we needed a logarithm, right? So, here is how we write the logarithm. A logarithm has a base. So we read this as log base 3 of 9 equals 2. So look here. 3 was the base, 3 is the base. The answer to a logarithm is always an exponent. 2 is the exponent, 2 is the exponent.
So it's like a cube root, but it's not really.
Yeah. Sort of. Okay. So let's get some practice with this. Okay, so 2 to the 5. How much is that? 32. Now the way I want to write it in logarithmic form is log base something. What's the base here? 2. Log base 2 of 32. A logarithm's answer is always the exponent. The exponent here was a 5, so 5. You see that? The way this is read is log base 2. This is the base. It's the base of this power here. And every base has an exponent. So if the base is 2, the exponent is 5. Okay. What about here? 4 squared is 16. So how am I going to write that?
Log 4.
Log base 4 of 16. Now look, I know this is not the complete one. Log base 4 of 16. If I had this, what's the answer to this going to be? It's going to be the what? The exponent, right? Okay, so if I were walking down the street and I saw a billboard, and on the billboard it said log base 4 of 16, I'd look at that and I go, oh, someone's looking for the exponent of 4 that would give them a 16. That's what I see that as. Somebody's looking for the exponent of the base that would give them a 16. Okay? All right? So this equals 16. Now I've got the logarithm. 2, sorry. Now I've got the logarithm. Okay? Where is the base here? What's the base? Which 3? Is it the 3 on the left or the 3 on the right? The 3 on the left. So this is the base, and every base needs an exponent. What's the exponent? The other 3, it equals 27. You see how that works? Your success in logarithms is based only on, just that one fact. A logarithm is an exponent. There are many, many shortcuts out there. And if you have, a friend, a sibling, a parent, a tutor, whatever, the neighbor who's helping you out, and they're like, oh, let me show you this thing, and blah, 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 blah. You got to make sure, and you say to them, my teacher really wants us to look at the exponents and the bases here. Okay, because this is how you're going to be able to do everything else that's coming. All right? It's not about getting the answer. It's about understanding so you could do the other stuff. Okay? All right. So here's another way of writing the same thing, right? Base, exponent is the answer to the log, exponent, right? And that is x. That's the value that goes there. So one more time, the answer to a logarithm is always a what? Exponent. Yay. Okay. So here, we're not solving anything. We're just writing in exponential form. Okay? So, what's the base here? 3. Every base needs an exponent. What's the exponent? 2 equals 9. People will tell you this thing about a snail method. This is what we're going to do. Because to solve equations later, I want you to look for the base. I want you to look for the exponent. Okay? All right. What's the base here? 10. Every base needs an exponent. What's the exponent? -2 equals 1 over 100. All right. Go ahead and tell me the next one. Correct. Okay? Now, we're going to do this the opposite way, or we're going to go the opposite direction. Write in logarithmic form.
Log 5, 125 equals 3.
Precisely. So look, we need log of a base. What's our base here? 5. Log base 5 of 125, it must equal the exponent. The exponent has to be the answer to the logarithm. Okay? Log, okay, base goes here. Base is 27. Exponent goes here. What haven't I used yet? Here. The 3. Okay? So log base b of this number must equal the exponent. Okay? Guys, put your calculators down for a minute. We're not using our calculators for now. Please. Here, tell me, log base what? 6 of equals -3. Okay? So far, we haven't done any math, really. We were just rearranging the numbers. Yes. Evaluate each expression. Evaluate means find a numerical answer, right? So now, what's the answer to a logarithm always? An exponent. Every exponent needs a base. What's the base here? The 3. If this is the base, I need the exponent of the base that gives me 243. So what I'm looking for is 3 to the what is 243. And sometimes it's just obvious, you know, but I'll let you, do trial and error on your calculators right now.
Is that how you do it?
I mean, okay, maybe for this one, but, for some of the others, we really should know.
Or like there's like a method to besides trial and error. Like
Eventually you'll
know.
just know the basic ones.
Okay.
So how much? 5, exactly. So since the exponent is 5, the answer to this whole problem is just 5. Okay? Be careful to not put 3 to the 5 as your answer, right? Because then you're saying your answer is 243. It's just the exponent. Okay? All right. Here, what is the exponent of 3 that would give you 81? 4. So this stuff really will be on a non-calculator section, right? And I will give you manageable numbers, right? So 3 to the 4 you should know. 2 to the 4, 2 to the 5 you should know. Okay? Yes.
The exponent we don't know. You mark that as 8, an x.
Huh?
You got a question mark?
Oh, either. It's up to you. Okay. So here I'm looking for this. Look, I'm asking 1/8 to the power of what is 512. Oh, look at that. Okay, so first and foremost, how do I use an exponent to convert from a whole number to a fraction? Negative, right? It's a negative. So negative exponents.
Oh, so you would find out what the exponent would be, and then you put it in the
That's exactly what you do. That's exactly what you do. So negative exponent converts between fraction and a whole number. All right. So exactly as Samson said, I'm looking for the exponent to go from 8 to 512, and we just said that that was 3, and then you add that extra negative in order to go between a fraction and a whole number. Yeah, right? Yeah, that's not too bad at all. All right, so let's do the next one. What's the base? 1/6. What's the exponent? That's what we're looking for. And we need that to equal 1/216. So now here's the question for you. Are we going between fraction and whole number?
No.
No. So do we need that negative?
No.
No. Okay, so what's that base going to be? A 3. So it's just a basic 3. Okay? How cool is that? All right. Speaking of exponents, let's go to some of my favorite exponents. You always know my favorite numbers are 1s and 0s, right? So, and you know that when it comes to exponents, a 1 and a 0, those are kind of special, right? Okay, because what's any number raised to the power of 1? The number.
Can we say itself?
Yeah, either. And any number, Ethan, raised to the power of 0 is 1. Okay? So, let's do some of these. 2 to the 0 then is 1. 3 to the 0, 1. 4 to the 0, b to the 0. Okay, so let's write these in logarithmic form. Let's do number 2. 3 to the 0 is 1. So log base what? 3 of 1 equals 0. Okay, again, if I were walking down the street and I saw this on a billboard, what would I say to myself? Oh, 3 to the power of 0 is 1. Okay, so what would that one look like? Log base 4 of equals 0. And then what about this one? Log base of
1
equals
0.
Okay. Any conjectures? Any patterns?
It's the same way you write it.
Okay, there is definitely a same, but now let's not use pronoun it. Tell me specifically what's the same and what's different. Yeah, Ariella. So, okay, is the base changing? Uh-huh. Right. So, no matter what the base, right? If we have log of 1, we're going to get a what? 0. Okay? That's it exactly. That's it exactly. So, if you have a logarithm, doesn't matter what the base. If it's a logarithm of 1, it's always 0. Okay? So, if you are walking down the street and somebody tapped you on the shoulder and said, hey, what's log of 1? What are you going to say?
0.
0. You don't even think about it. 0. All right, let's do the next one. 2 to the 1?
2,
3 to the 1?
3,
4 to the 1?
4,
B to the 1?
B,
Okay, so let's write these. Log base
2,
of
2,
equals,
1,
okay, log base
3.
3 is 1.
So the two numbers would be
Yeah. Log base 4 of 4 is 1. Log base b of b is 1. So who can articulate that in English, in words? Using words. Think about that. We want, just using words, a sentence. How could we articulate that? How could we say that? Yeah.
well, the base and the answer are the same, which that's it to be 1.
Right. So it doesn't matter what the base. If you want your value to be the same, then the exponent is 1. Right? So the property says log base b of b is always 1. Okay? All right. So now, here's a question for you. If you had log base 2 of 8, how much is that? 3, right? Because the exponent of 2 to get you 8 is 3. What's the base? 2. Every base needs an exponent. What should the exponent be so we can get an 8? 3. Okay, so what if you had log base 5 of 5?
It's 1.
It would equal 1. What's the exponent of 5 to get you a 5? 1. Log base 29 of 1.
That's not 0.
0. What should the power of 29 be in order for you to get a 1? 0. Okay? All right? So now I have a cute little handout for you. It's both. I'll give you the practice quiz. Okay, so what about this one? Log base 5, let's connect to chapter 7 of root 5. Oh my
You have to
goodness.
square the 5.
Okay,
1/2.
you don't, oh, 1/2, there it is, 1/2. So we can't square because then we're changing the problem. But since logarithms are all about exponents, can I write the root 5 as an exponent in exponential form? So like 5 to the 1/2,
Yeah.
Yeah.
right? So now, what should the exponent of 5, what should the exponent of this be so that I get 5 to the 1/2? 1/2. Right? So what should the exponent of this blue 5, what should I make the exponent of the blue 5 so it equals 5 to the 1/2? 1/2. Okay? All right. So let me give you this one. I want you to work with a